This is part 8 of the GCSE chemistry topic, bonding. It is a dual award topic, which means it's obviously in the triple award as well. In this video, we're going to take a look at fullerenes and graphene. I'm going to go through some key information. There's a few tasks for you to try. I'm going to recommend that you pause on them, have a go for yourself, and see how you do. So within here, we're going to look at the structure of fullerenes and graphene. We need to be able to recognise them by looking at the diagrams, and we need to come up with some uses of them. And we can see here lots of information. Fullerenes, we've got a C60 molecule here on the left in a football shape, but you can get them in other shapes as well. So you might see cones or rugby ball shapes, etc. In terms of the cylindrical fullerene, this would be a nanotube. Now, these are very thin cylinders. They're incredibly useful. They're great conductors of electricity, and they can be very, very strong. We've got more information on here, and I'm not going to read all of this, but I'm going to recommend can pause and take a look. I'm going to pick out some of the highlights that you might want to remember. So I've already spoken about nanotubes having a very high tensile strength and being great conductors both electrically and thermally. That's because they're based on graphite. They've got a delocalized electron per carbon, and that delocalized electron can carry charge through the structure. A really important use of fullerenes is in drug delivery. It can be a cage-like structure, which can mean that you can take a drug and actually transport it to the part of the body it needs to go to, so it won't get broken down elsewhere. The other thing I'm going to take a look at is that graphene is one atom thick. This shape will be really familiar to you, this planar hexagonal structure. That's one layer of graphite. Now, when you break that down, and this was first done in a really crude way with sellotape in a lab, but it's done much more systematically now, but you get down to an individual layer. It is an excellent electrical and thermal conductor, and let's now take a look at some questions related to this. So in terms of how fullerene is used in medicine, well, we've already said that it can be used to help deliver, for example, cancer treatments to specific sites in the body. It provides a cage to carry the medication there. A couple of questions here, not so important for the exam that you might be doing, but the name actually comes from Buckminster fullerene, buckyballs. And if you take a look at the Epcot Centre at Disney, and you can Google that at your leisure, you'll recognise the shape of it when you then compare it to the fullerene that was shown earlier in the video. And the first fullerene was C60H60. Couple more questions. Considering the properties, why might graphene be useful in the manufacture of bulletproof vests? Well, we spoke about the high tensile strength. By consideration of the properties and structure, suggest why both graphene and fullerene are excellent conductors of electricity. Well, this is because of the delocalized electrons that can carry charge through the structure. And we're going to see that in later videos when we look at metals, and we've already seen it when we looked at covalent bonding and giant covalent structures earlier in this series of videos. In terms of similarities and differences then, graphene is similar to graphite in the sense that it has a hexagonal planar structure. Each carbon is bonded to 3 other carbons. That means that it does have a delocalized electron per carbon, which makes them good electrical conductors. Graphene is actually a better electrical conductor than graphite. But in terms of the differences, it really comes down to the graphene being one layer thick, whereas graphite has multiple layers, which are held together by the weak intermolecular forces. And that's due to the delocalized electrons that we can see. So that takes us to the end of this video. Thank you for listening, and goodbye.